All right. So we're going to talk a little bit more about functions. Today, specifically, we're going to look at domain, range, intercepts, and other properties. And those other properties are going to include where a function is increasing, where it is decreasing, where it's remaining constant, all sorts of good stuff. All right, so just a few definitions. Increasing is when a graph goes up as we move from left to right. Everything is in terms of left to right with graphing. So increasing, the graph is going up. Decreasing, the graph is going down as we move from left to right. It's constant if it's not going up or down. So it's just a straight line, a horizontal line. Another thing that we'll look at is absolute maxima and absolute minima. It's just the largest value for the maxima, the largest y value in the whole function. And the absolute minima is the smallest y value in the whole function. Most often, graphs won't have an absolute maxima or an absolute minima, but they might have a value that compared to everything around it is the largest. We call that a relative maxima. Or if it's smaller than every other value around it, it's called a relative minima. So we'll see that, like I said, in some of the examples that we do. The domain, all the possible input values. The range is the set of all possible output values. And then we'll talk about x-intercepts and y-intercepts. So the x-intercept is a point where the graph crosses the x-axis. It's the solution to the equation, whatever our function is, equals 0. So that's why we've talked about solving quadratic equations and solving by factoring and all of those things. The y-intercept is the point where the graph crosses the y-axis. To find the y-intercept, you plug 0 in for x and just evaluate the function from there. So a little bit easier to find the y-intercept than the x-intercept. And there can be more than one x-intercept, but there's only one y-intercept if we have a function. All right, so this is what it's going to look like. Graph the function x cubed plus 5x squared minus x minus 5. And our author talks about this as using the shotgun approach. So the shotgun approach is we're going to just pick some values to plug them in. So I'm going to pick, I don't know, 0, 1, 2, 3, 4, and 5. Now, one of the nice things of choosing 0, I'll know what my y-intercept is right away. So if I plug 0 in, I get 0 cubed. What's 0 cubed? 0. Plus 5 times 0 squared, which is 0, minus 0, which is still 0, minus 5. one of the things that can be helpful is looking at using a graphing calculator. So I'm going to show you a way that you can find those values pretty quickly using a graphing calculator. You could also use the graphing calculator to double check to make sure your graph is correct. But for the values, there it is, I think. All right, let me go back to here. All right. So what I could do is using a calculator like a TI-83, I could put my equation in, x cubed plus 5x squared minus x minus 5, right? And I can look at a table of values. So in this case, I started at 0 and I'm going up by 1. And if I press second graph, it gives me my table in just a moment. There we go. So I can actually just write these in. Wow. $64, $135, $240. So clearly, we're not going to be able to graph all of those points. They're just not going to fit. But I can definitely graph 0, -5. I can definitely graph 1, 0. And everything else is off of my graph, but it's going to increase through there. So what I want to do, and I'm going to actually skip over part A for just a minute. Where is the function? Oops. Where's the function increasing, decreasing, or constant? I'm going to skip that. I'm going to skip the maxima and minima, but I want to find the intercepts first. So I'm actually going to do this kind of backward. Come on. So the y-intercept, we already know. Oh, now it's going to be nice, huh? The y-intercept was 0, -5. For the x-intercept, We're going to take our equation and set it equal to 0. In order to factor this, I would factor by grouping. I'm going to group that together. I'm going to group that together. Bless you. Is there a common factor in x cubed plus 5x squared? There is a common factor of x squared. Oh, I love it when this thing doesn't work. My favorite time of the year. There we go. And we'd be left with x plus 5. Is there a common factor in negative x minus 5?
Yeah.
Minus 1. X plus 5 equals 0. So then, if I factor out the x plus 5, I'm left with x squared minus 1. Can I factor x squared minus 1? So that's going to factor. It's a difference of squares. It's going to factor into x plus 1. And x minus 1. So for my intercepts, I set each of those equal to 0. But I think in this case, it's pretty easy to see. We would get x equals negative 5. X equals negative 1. And x equals positive 1. So on my graph, I'm going to cross the x-axis at negative 5, negative 1, and 1. All right. So my graph should look something like this. Whoops. Okay. So increasing as I go from left to right, well, look, it's increasing here. And it's increasing here. So for increasing, we always want to write that as in interval notation. So it's increasing, and I'm going to wow, that's impressive. From negative infinity to -2, and from 0 to infinity. And we can double check that on the graph. Yeah. Oop, I think it's actually -3. I messed up. And then in this case, it's decreasing from -3 to 0. The maxima and minima, there aren't any, because this graph goes all the way down as low as you want it to go and all the way up. If it asked for relative maximum or minimum, then we'd have a relative maximum here and a relative minimum here. It doesn't ask for it, so we don't need to worry about it. and then domain and range. What values can we plug in? As long as it's a polynomial, the domain is going to be all real numbers, or we can say negative infinity to positive infinity. And the range, that's where the graph really helps. In this case, is there a y value that we can't get?
That we can't get?
What's that? As an answer, right?
No, I don't.
Yeah, no, so that's going to also be from negative infinity to positive infinity.